Hi, I'm Sam. I'm a statics TA. Let's start out by reviewing some trig. We are going to be using trig on right triangles in statics to do a lot of things. First off, let's start out with the hypotenuse, which is the long leg of the triangle. And we also have the opposite side from an angle, which is the side across from the angle theta, which is circled. And then we have the adjacent side, which is next to the angle theta. Let's start out with some trig identities and trig review of the formulas. We have tangent theta is equal to opposite over adjacent, and sine of theta is equal to opposite over the hypotenuse, and cosine of theta is equal to adjacent over the hypotenuse. A simple way to remember this is SOHCAHTOA. In the traditionally defined x and y coordinate system, we have that the coordinates are the hypotenuse and some angle theta away from the x-axis. We then use that to break the x and y coordinates down into their component forms. And we have that the hypotenuse times cosine of theta is the x-coordinate, and the hypotenuse times sine of theta is the y-coordinate. But this isn't always true, as we will see in an example later in this video. These formulas of hypotenuse times cosine of theta equaling x and hypotenuse times sine of theta equaling y are traditionally used in classes such as vector calc and a lot in this class for coordinates, but they aren't always the case. Here's an example where the traditional coordinate system, which I described earlier in the video, is not the same for the trig stuff. In this case, the x component is opposite the 30-degree angle of this 10 kip force, and the y component is adjacent this 30-degree angle. So thus we get negative 10 sine of 30 degrees being the x component and 10 cosine 30 degrees being the y component. The x component is negative because the 10 kip force is pointing to the left in the x direction, and the y is positive because the y component of the force is pointing up.